Let's first write the functional requirements.
Write the heading WhatsApp design.
Sure. Uh, yeah, so functional requirements, first requirement would be that user should be able to send peer-to-peer messages. Then there should be a group chat functionality. Uh, then we will have there should be support for uh, offline support for uh, receiving messages once user comes back online. Group chat may we will have 100 users limit for a group. Yeah, last requirement could be that we have support for uh, attachments in the messages. Any other requirement that you guys think we should cover apart from this?
Sharing image, multimedia message like
Yeah,
that.
that will come under the attachments.
Okay.
So this will have image or PDF or any other file formats. Anything else, guys? Cool. Then let's move to the non-functional requirements. Uh, Non-functional requirements may we should have reliability of message delivery, which means that at least once delivery of messages.
Hey Prashant. So probably like as an interviewer, right? I can ask you to consider groups, voice call or video calls as well, right? But you may defend saying that I mean we'll cover this, and then if the time permits, right? I think you have not mentioned in the functional requirements, right? You can say that fifth and the sixth point as video or voice calls as well,
Sure.
or you can mention by yourself and then say that I'll consider them to be out of scope in the interest of time.
Yeah, I mean, sure. These obviously video and voice calls will not cover for now. I mean, uh,
Or just write them under like another section saying out of scope.
uh, cool. Uh, so we'll have reliability of message delivery. We'll guarantee that at least once the messages will be delivered throughout the system from the client to the server. Sorry, from the sender to the receiver. Uh, then we will have system should be highly scalable. Let's assume we have the system is processing 1 billion messages per day. Uh, so if we estimate the throughput for it, throughput is approximately 10 to the power 4 TPS. Or let's say there are 1 billion users who are active per day. Uh, and every user has sends 10 messages. So the TPS will be 10 to the power 5 TPS. Then the system would be for the between availability and consistency, we will prioritize availability of the system over the consistency. So we'll go with an eventually consistent system. So what I mean by this availability is prioritize over consistency. It means that uh, we'll ensure that the message which has been sent by the sender, uh, we do not ensure that the moment that the sender sends it, all of the messages will be delivered. If there is some failure, then there can be internal retries that we do, but ultimately these messages will get delivered. But it will not happen that the system rejected the message from the sender and saying that the functionality is not available for sending messages. Uh, then we will ensure that system is recoverable from failure of components. So fault tolerance. Uh, any other non-functional requirements that you guys think should be covered?
Latency, I think, is an important thing.
Yeah. Latency, let's say we guarantee an end-to-end latency of less than 200 milliseconds for peer-to-peer messages. And for uh, for the case where user, then the next is latency in case of user coming back online. We'll guarantee that we will user will receive all the messages within 5 seconds of coming back online.
I mean, as part of another thing I would like to add, as part of functional requirements, can you also talk about briefly about if they are online or not, and also the read or the read receipts and what do you call delivery receipts as well?
Yeah,
Brief.
that will be so we'll have to support for the delivery receipts of message status and or delivery receipts of a message. So system will be uh, supporting this feature as well.
And online status as well.
Sure.
We'll see if we have time. We'll cover this. Otherwise,
Cool. Anything you guys think on the non-functional side or on the functional side we should add? Uh, let's go to the entities. Not exactly. In case of media, the thing would be that we'll upload the media via a separate flow, and I mean, we'll just upload the file into a blob storage via a separate flow, and then we'll just pass over the link of the media file, which will be shareable between the users. So, latency of the particular communication latency would not increase, I believe, in that case.
Yeah, makes sense. Go ahead, please.
Okay. Let's talk about the entities. First entity would be message. Then we will have uh, we'll have message case. Then we will have an inbox, which is basically message is the raw message. Let's say it contains the content. We assign a message ID. Let's say we have the sender ID, the receiver ID. Let's say there is any media link in this message. So that will be the message, and inbox would be something like for a particular message ID, what is the status of the delivery? The delivery status, whether it is sent, delivered, and read. Uh, then we will have groups. Uh, this message can also have a group ID with a receiver ID. If it is had to be sent to a group, it will have a group ID. Groups will have an ID, and it will have user ID. Then we will have a user entity, ID, name, and other metadata of the user. And we will have the user uh, include the send timestamp for a message. Okay. Send timestamp we can include. It would be helpful for uh, yeah, it will be helpful for ordering the messages. We'll have one more table over here, which is the server user mapping, or the server uh, device mapping, which is basically a server ID, device ID, and the status, whether it is online, offline. . So user sends a P2P message that goes to the message table. An entry is created. We create an entry in the inbox. If it is a group, we put in a group over here.
Do you want to like have that feature of admin as well? So you may require some other
Uh,
attributes for
what do
it.
you mean by add feature?
So let's say the group admin, right? I mean, with ID, name, and user ID, right? I mean, we won't really get to know who's the admin of that group.
Okay. Uh, okay.
And groups will have just user ID or list of user IDs.
It will have a list of user ID. So a group ID will have a one-to-many mapping. Uh, I mean, how what we can do is that we can just generate one more group ID, and this column can be just a database identifier. This group ID will be a one-to-many mapping between a group ID and user ID.
Yeah, you can probably write down as list of user IDs.
Yeah, sure. Uh, we can have user role, like whether a user is an admin or a participant.
Yeah.
Uh, and we are sending a message to the group. Uh, okay. Uh, Again, we'll just revisit uh, at some later point in time if, according to the system, we have to make any changes to the entity. Uh, let's go to the APIs. So the first API would be that we want to make a WebSocket connection for a particular. So like we want to send peer-to-peer messages. So we'll be just using the WebSocket protocol for opening a persistent connection from the client to the server, and via that particular persistent connection, the client should be able to send and receive messages uh, from the server. So first API would be that to create a WebSocket connection for a particular user ID. So let's say we pass in an authorization key of a user ID, and what this returns back is basically the connection. Uh, then let's say we have send message API, and this returns back a message entity. And inside the send message API, we have the content, the sender ID, the sender ID, and all of the other metadata that is sort of required. This is basically all of the metadata that is there in the message table that will be passed in the send message API. Mm. Then we will have an API to get the message. Uh, in case a user comes back online. So they will call an API to get a message, and we'll have a limit of, let's say, we poll 50 top 50 messages at once, and we have a cursor based pagination. And what this returns back is a list of messages, or response may we get a list of messages, and the next offset. These offsets will be basically the message IDs from the inbox table, which are currently which will be in the received status and which were not sent uh, because the particular user was offline. Uh, we will have a post group API which will return back a group entity. And then we will have an API to sort of add members to a group, and this will take in a list of users. This should take in. Uh, yeah. Any other APIs that you guys think we should create apart from these?
Should there be an online status and for the red receipts or anything? Red or
Yeah.
delivery times?
Uh, so read receipts would be okay. Yeah. Read receipt update के लिए we need an API. Uh,
Folks, please ask questions, right? Question the design, right?
okay. Delivery receipt. We have the message ID, and actually we can have a list of message IDs. And we can have a health API or online status API, uh, which passes in a user ID. And this is basically a heartbeat kind of a mechanism that we will create, wherein the client will be every 30 seconds, the client will just call this particular API to register that the status of the user is online.
Yeah, I have a point.
Yeah.
Hey, Prashant, yeah, this is
Hmm.
nice and elaborate thing. Uh, Thank you. The one part that I want to mention is you can you can say that there are some core feature and there are some additional feature, right? So core feature, all of them related to messages.
Hmm.
Additional feature, you can say that online status and other thing because you have only maybe 30 minutes more, and you might not able to go into depth of let's say online status, how to reflect. Maybe you will take more time on messaging front, offline message delivery, and other thing, right? So you can you can actually mention this part, and while designing the API also, you can skip that part that is not core, and you can come back to later if let's say as an interviewer they want to probe more on the kind of those features. Okay,
Mhm.
yeah, that's my 2 cents.
Yeah, that is fair call out. Actually, we extend more than an hour in this call. But yeah, from an interview point of view, that is a fair call out that we should be discussing the MVP, uh, that what would be the bare minimum that we'll support in the design, and if there is any additional requirements, then like Kuldeep mentioned that the core features are the peer-to-peer messaging and probably the group chat, and the rest of the read receipt and status delivery is something that, or attachments is something that we can support, add support for at later point in time if time permits.
Yeah, I think attachment should be fine if you include along with message. Read receipts and status could be additional feature.
Yeah. Oh,
Yeah, please go ahead.
hmm. uh, okay, let's go with a high level design, and then we'll do a deep dive. Uh, let's say we have multiple clients. We have a L4 uh, load balancer for creating the WebSocket connection, and we have an API gateway. Say we have a chat server. It is a server device mapping, uh, message inbox. So client message, client first tries to create a WebSocket connection chat server, uh, and the chat server logs an entry into the server device mapping table saying that for this particular server identifier, what is the device ID of the client, Uh, so here we will pass in the device ID as well. What is the device ID and the particular user ID will mark the status as online. If entry is present, obviously we'll just update the server device mapping, else we'll just create an entry. Then let's say all of the clients have their connections on the chat server setup. Uh, so now if a particular client is trying to send a message, uh, let's say client 1 is trying to send a message to client 3. Uh, so what will happen is that client 1 will use the web socket connection and send the message to the chat server. Chat server will log the message into the message table uh, for reliability purpose, that we do not lose the message. So we'll make a log of the message in the message table, and then we will uh, create an entry into the inbox saying that for this particular message ID, we'll just generate the message ID. This will be a unique identifier which is generated by the chat server, and every message entry would be identified uniquely, and it will make an entry with the delivery status as received. Then chat server inside this particular API, the send message API, what it will do is that uh, it will uh, it will fetch the uh, receiver IDs, server ID entry from the service server device mapping table. So it will make an query, and if it will find that the particular client is online, then it will uh, mark the particular. It will send the message to the client 3, and it will mark uh, the delivery status as sent. Now, once the client has, once the
So,
message has been, yeah,
sorry to interrupt. I mean, probably this did not come out very nicely, right? That say C1 wanted to send a message to C3, right? You were going to this server device mapping table, right? Why? Because C1 is connected to some instance, let's say S1, and C3 is connected to some instance, let's say S2, right? So basically, there would be a coordinator who would be kind of sending the message to the to another instance, right? That is the reason that we kind of refer to this table. Probably you can just
yeah,
reiterate.
the partitioning of the chat server, that will go in the deep dive. So for now, I'm just giving a design wherein every
Okay.
client
High
is
level.
connected to the same server.
Cool, cool, cool. My bad. Sure. Cool.
Uh, so yeah,
Yeah, I
uh,
want to add to what Pratik has mentioned. Sometimes, right, it's a very fine line that what you have to cover in HLD, what you have covered to deep dive. Because as a kind of viewer, I'm just thinking that why you are not covering where customer could be connected with different chat servers, right? Once we are explaining the message and delivery. So yeah, that's where we have to just balance that how much depth you have to go in HLD and then take in deep dive.
mm, sure. Uh, Maybe. I'll just speak it up front so that such confusions would be avoided. For now, we'll just focus uh, a single node chat server and the end-to-end flow of message delivery in the HLD, and in the deep dive, we'll do the partitioning of the chat server, and where we will have multiple chat servers and client can be connected to any of the chat servers, and we'll do the end-to-end uh, uh, sending and receiving of messages. Uh, cool. Uh, so user is now able to send the peer-to-peer message. Uh, let's say user has to sort of uh, receive the messages once the user comes back online. Okay. Uh, so that particular functionality, what we can do is that we can have one more chat history server, and client can call the particular uh, API to get the chat history from a particular offset for a particular for a user ID. Uh, this should be an authorization key here. And we should have the sort of uh, okay. One place where this design is not extending is how we will integrate the group chats, because uh, here how this chat history API is responding is that we are trying to fetch the message, and we are giving the user ID as a parameter, and we are giving the offset and limit. But this would work if there is a case of that there is just one user with which this particular user is interacting, uh, or there is just peer-to-peer functionality. But what in the case of group chats? Uh, in the case of group chats, there would be a different group IDs. Uh, but yeah, let's say in case of group chats, uh, if I have two options, I can in the inbox I can just, let's say, create one entry each for the user ID. Uh, so in case of a group chat, what will happen is that let's say I create when I receive a message for a particular group chat, I create the one entry inside the message table, and let's say there are 50 users in the group. So for all of those 50 users, I create 50 entries with delivery status received inside the inbox table. So it is the same message ID, but there are different user IDs with different delivery statuses. In that case, what can happen is that if I want to fetch the list of messages which have not yet been uh, sent for a particular user, I'll just have to query the inbox table for the user ID. And I can do the pagination on the message ID. That for a user ID, what are the message IDs that are currently in received status, and I can do the pagination logic on top of that. And yeah, I can get that that way. Do you guys think that would work, or do you think there should be some other way to it, better way to it?
Yeah, move on, Prashant. If people are not responding, just move on.
Okay.
But yeah, I
Uh,
would encourage people to be more interactive, right? Ask questions.
yeah. Uh, cool. So there will be a chat history server, which is sort of exposing the get message API, and chat history server will sort of call the inbox table to get the messages which are in received status and they have not yet been sent over to the client, and they will be sent uh, via this particular API. Uh, Apart from that, we will have uh, a group chat service. This again, client can call the group chat service for creating a group and adding users into the group. So this will be all part of the same database, and just kept two diagrams for simplicity of the design, for being able to present it easily. So yeah, that would be the HLD for the parts of uh, peer-to-peer messages, group chat functionality, and send receiving messages once user comes back online. Yeah,
Prashant, did I miss out? Like you were pulling the messages, instead of the messages getting kind of pushed to you to C3.
uh, so there are two mechanisms for message delivery. There is a peer-to-peer message delivery, wherein C3 is connected to the chat server,
Mhm.
and if C3 is online as per the server device mapping table, uh, then the C3 will directly receive the message. That is, the chat server will directly send the message to the C3
Mhm.
and update the status of the inbox. In the inbox, it will update the status as sent for that message. If C3 is not online, then chat server will not be able to
Okay,
find
correct, correct. So this was for the offline case, right? Okay, sure.
the chat history service wala flow is for the offline case.
Sure. Move on.
Yeah. Cool. Let's dive deeper into the design, and let's scale it up. There are scale bottlenecks that will have to partition the chat server, and we'll also have to do the partitioning of the message table, because chat server can have, according to our numbers, we will have a billion active users per day, and let's say concurrently there are a million users who are connected on the platform, million or 10 million, and a chat server will have to, one single chat server won't be able to handle that much of a load. Uh, Similarly, uh, we are generating 10 billion messages every day. So we'll have to also do the partitioning of the message table and the inbox table. And also we'll have to do partitioning of the server device mapping table, because we will have a billion entries which are created uh, every day into this particular table. Even the groups will have to partition. let's how we will handle that. Uh, let's say we have this load balancer and we have uh, multiple chat servers. And we'll have to keep a coordinator. So okay, uh, cool. So now that we can see that in this design, what we have done is that we are partitioning uh, the chat servers into multiple instances so that we can scale it up for the load. Uh, let's say there is a coordinator node as well, which is sort of managing this cluster of chat servers. So the responsibilities that the coordinator will handle is that it will sort of do the orchestration of these chat servers. So anything like if a chat server goes down, uh, then the coordinator node is sort of responsible to reconnecting the clients to the new chat server which is coming up. It will be responsible for pulling up a new server and sort of reconnecting the clients to that particular server. Also, the coordinator would be responsible for sort of uh, uh, telling the client that which particular chat server they can connect the WebSocket connection to, because now that we have multiple chat servers at our end. So this request, I believe, from the client, it has to first the flow will be the connection API flow. It would be something like the coordinator sits in between. So this request goes first to the coordinator, and the coordinator sort of calls the database, and we'll have to keep one more table, which is let's say server status, and we will have a server ID, number of connections, let's say for now we have these two and the health health status, whether it is active or inactive. So the coordinator sort of what it does is that it makes a query in the server status table, and it fetches a server ID uh, to sort of which is having, let's say we have already we already have in the system, we have a configuration that what is the maximum number of connections that will allow on a particular chat server. Let's say we'll just allow 500 connections at max on a particular chat server. So it will just query the server status table, and it will fetch the server ID which is having less than, which is currently having free connections, and then what the coordinator will do is that it will return the particular server ID to the client, and the client will make the WebSocket connection to that particular server ID. So there will be one more call from the client which will make the WebSocket connection. And then the other flows will remain the same, that uh, I mean it will not remain the same, but in the other flow that wherein we have to send the message via WebSocket connection, the in that case the client will directly talk to the chat server, and there will be no involvement of the coordinator node in between. uh, I hope this part is clear, or if there are any doubts on this part or any questions. Cool. Let's move forward. So the tables involved over here would be server status and yeah, server status and server device mapping. And then let's say now the client has to send a message from client 1 to client 3, and now what the problem over here is that client 1 is sort of connected to server 1, and client 3 is sort of connected to server 2. So client 1 cannot send the server 1 cannot send the message directly to server 2. It has to pass the message via a channel. So let's say we have a Redis instance, and uh, the server 1 is sort of subscribed to a particular to updates on a sorted set in a Redis, and the server 2 is also sort of subscribed to updates to a particular key in Redis, and uh, server 1 can sort of push an event into the particular yeah.
Prashant, somewhere lost you, right? What was the purpose of coordinator, right? See, when C1 is sending a message to C3, right? So
Mhm.
now, the message comes to S1, right? and
Mm.
S1, let's say, talks to the coordinator and says that, okay, this message is meant for C3, right? Tell me, please tell me the what is the what is the server instance for it, right? So coordinator says, okay, this is S2, right? How do I now deliver to S2? I mean, server one cannot deliver to S2. I mean, it will go via coordinator, or how? I mean, that flow is not very clear to me. Okay, what is the role of the coordinator here?
No, so the coordinator is just for the service discovery. So coordinator node will just tell you that what is the sort of server to which you want to route this message to.
Correct. Okay.
Now, what these servers, how these servers are communicating within between each other is via the Redis. Uh,
Okay.
so in the Redis only, these servers have subscribed to a particular uh, a pub sub kind of a mechanism. Like
Okay.
I, uh, so if
And what is the partition of PubSub?
the partition of pub sub, uh,
Which, how many PubSubs are there? It's user specific PubSub or server
okay,
specific?
okay, that you're asking. No, no, it's a server specific pub sub.
Okay.
Yeah. So
And how do you know that I need to send to S2? You need to know that which user is connected to which server, right?
yeah, so that the coordinator is sort of calling the server device mapping table. So whenever a client is sort of creating the WebSocket connection, we the coordinator makes an entry into the server device mapping table that a particular user ID, what is the server ID to which the user is connected.
Hmm.
Um, I have one use case here. Let's say there are these two users, C1 and C2. Both are on the same server, S1.
Hmm.
So I will prefer that the message should get delivered instantly instead of going to coordinator, because it will save us a one round trip there. Like,
Okay.
yeah, that could be a use case, because if we are users are in the same region, Mumbai or whatever, there will be a high possibility that they will be on the same server. So, so this will include the latency. I think, I feel basic.
Yeah, I mean, that's a very good question, Amol. And
Yeah.
yes, Prashant, I think that's viable as well, right? Because see, once the message comes to S1, right, it will go to the coordinator only when it doesn't know, or okay, Amol, to this, right? How will S1 know that this S1 only knows that this message is for C3, right? It doesn't know which server C3 is connected to.
Right.
Yes.
So it has to go to the coordinator, right?
Hmm.
Yeah.
I think we can't save on that round trip.
No, it can maintain a local cache, huh?
Yeah. Like something like sharding.
But that is too complex. So basically, I would prefer that each server is doing minimal job and consistent job. So predictable work should be there with server. It should not happen that lot of messages is coming to S1 and user are connected, so it works. It will get overloaded, right? If it is doing lot of work. So I think this is fine if we offload to Redis and let that happen. Maybe S1 also has same thing, or maybe some different fleet can do this, right? S1 is just for relaying the message, or maybe the server, chat server, it's kind of relaying the message, and another fleet is doing this message delivery. That could be also option.
So, like when you're saying that S1 is just relaying the message, that it is just sort of logging the message and
So basically, S1's responsibility is to do generally, as a rule of thumb, we should avoid doing more than one work in one transaction. Right. So S1 responsibility could be that put into maybe store or instead of going to database, if it's kind of overwhelming, put that message into some kind of persistent messaging
Correct.
queue, maybe Kafka, so that its job is done, right?
Correct.
And then someone wakes up or someone is working on that and pulls the message, put into DB, and then it has also responsibility to relay to, let's say, correct server where I can put it. That will give you retry possibility, persistence, all those things you can get there, and scalability also there.
Mm,
I do
okay.
agree on this, right? Because see, what is happening is if you go to the database, right, that's an IO operation, right? You have to figure out quick, right? You have to figure out quick where is the mapping for S2,
Mm,
right? And also, yes, if you want to store the message, you can't just go and store the message, go to the DB and then come back. That round trip is also a long one, right? So instead of this, right? So let's say if you're forwarding the message, just put that message into some, let's say, broker, right? Which will eventually uh, store it into a DB, and you forward
yeah,
that message.
that that makes sense. What we can do as per the suggestion is, let's say we add a topic. So what the chat server responsibility remains is that it will sort of, when it is received the message, it will sort of fetch the particular device, the server ID to which it has to forward the message to, and it will just push this message into the Kafka topic, and there will be a message coordinator which will be sort of consuming these messages from the Kafka topic and writing these messages into the Redis. And whenever
So you don't need Redis now. So
uh,
basically, there are multiple part. I thought about this problem a lot, maybe a couple of months back.
mhm,
So I just want to debate here because I'm also not very sure and discuss. So one option is Kafka topic, irrespective who is the, maybe the partition of Kafka topic is, let's say, receiver. That could be one, right? That this C3 is the one, so this partition this will go, and there is no different topic because Kafka you can have limited amount of topic because it's a heavy operation, right?
mhm,
Creating a topic and all those things, and then there is a worker fleet, consumer fleet. The consumer fleet, they are kind of listening to one partition at a time, and they are figuring out that this message belong to C3, so I need to send it to C3, right, via S2 or something. So that is one option. Second is, generally I have seen is that, like you mentioned in first time, that S1 is figuring out who is the coordinator and they are directly sending it to S2, not through Redis topic, because they now know that which server customer is connected to. They will send there. There is a kind of internal pub sub kind of mechanism. S2 will make sure that it delivers. Or if it's not able to deliver, then it put into maybe a DB where it can say that for offline delivery. Consider it for offline delivery,
mhm.
right? If something fails. So those are the two options that I just mentioned. There is one more option that we can discuss, but I want to understand from people that which one they think is more scalable. Uh, yeah.
I somehow feel that probably my point was taken in a different way. I did not mean that the message will go to the Kafka and then this message coordinator will come, because once you put to Kafka, right, when the consumer thread will be picking it up, I mean, we really don't have a guarantee right there.
Yes, you don't have a
Okay.
guarantee that
Okay.
when they will picking up, but generally they pick up in FIFO order, right? Uh,
Correct. That's there, but it is a real-time chat, right? I mean, it's a real-time chat. So somehow I feel that S1 has to figure out, and there has to be a system, um,
hmm. Yeah,
through a
for real
coordinator.
time chat, I agree. There could be some delay. So in that option, the better one would be, let's say, S1 figure out which server customer is connected to, right? And then
Mhm.
it delegates to that server, and then server's job is to send it to C3. If it fails, delivery doesn't happen, it's stored into, let's say, offline message store or somewhere, so that one other process that is working for offline, that may try to deliver it.
Yeah, so that is basically uh,
So that's where you need something like a zookeeper thing, like coordinator, right? That has like guaranteed information that this machine is connected to these many customer. This is their WebSocket connection and all those things, right?
yeah. So that particular server. So what I'm keeping in the Redis over here is basically from the coordinator or from this particular node, I'm getting the server ID uh, to which I have to route the particular message, and just the communication part is happening via Redis, wherein S1 has subscribed to a particular pub sub uh, topic in the Redis, and S2 has also subscribed to a particular pub sub topic. S1 is pushing the message to the pub sub topic to which S2 is subscribed to, so that
Yeah.
S2 sort of receives the message, and then it can forward the message to the particular client.
Yeah. Okay. Yeah, that makes sense. The other flow, right, which you say that you are sending something to Kafka topic and there's a message coordinator. What is that doing?
This particular flow is for the use case that let's say there is a lot of uh, work that is being done at the S1 end. We'll just add a asynchronism layer over here. So we'll just offload some part of the work uh, to the Kafka topic so that S1 can scale up better in this case.
Okay.
But the flow remains the same. Here, the instead of the S1, the message coordinator is responsible for offloading the particular message to the pub sub topic to which S2 is subscribed to.
Okay. So just to summarize, right, and probably you can do, what I understood from this discussion is that when the message is to be delivered from C1 to C3, right, it goes to S1. S1 talks to the coordinator. Coordinator checks its cache, right? Where is this C3 connected to? It says that
Mhm.
okay, this is to S2, and then S1 puts its message to the Redis of S2, let's say, right? And
Hmm.
S2 picks up the message from that Redis and then delivers it through that persistent connection.
Correct.
Yeah. Cool. Move on. Come on, quick.
Yeah.
15
Uh,
minute movement.
yeah. Okay. Uh, Let me just remove these parts.
Now maybe you can cover how does group chat works.
Yeah. So, group chats would be basically
Just a second. Sorry to interrupt.
mm,
Just recall there was a one solution to a problem similar to this in the URL shortener. So what I studied, they started with the single server, and when their application got like uh, got extended, they had the similar issue that which URL is on which server. So they use some mathematical equation to calculate on the basis of user. So can't we do that here as well? Just I was thinking, if some request come and by some algorithm we can, or by some mathematical means we can get its server name. If it's in the same server, then it will quickly respond back. If it's on the
uh,
different server, then we can go for the coordinator, and the coordinator will do its job. Just a thought I had in my mind.
the thing is that with URL shortener, the thing is that all of the data of the URL is managed uh, by the server itself. But here we don't have a control over like what client will get connected to what server, because the coordinator will try to evenly balance out the load on the different servers which are registered to it. Uh,
No,
they,
because what I understand that from load balancer we are getting request on server S1 then S2, and this S1 and S2 is sending request to coordinator to find out the server. This is how I understand this. So
right.
that's what. Yeah.
Yeah. If you look at the URL shortener example, what happens is that let's say user has requested for a URL
Sorry to
to
interrupt. Amul, we'll discuss this offline because there can be a lot of if and buts, right? Because that's a constant thing. But here, users can connect, disconnect, and all of that, right? So that's why.
Mhm.
Okay. So
Okay.
move on, Prashant, in the
Yes.
interest of time. Yeah.
sure. Uh, cool. There is the peer-to-peer message flow that we discussed just now. Uh, for the group chats, what will happen is that uh, let's say server one, let's say it receives a message from client one, uh, and let's say C1, C2, C3 are all part of a group, and client one sends a message on this particular node, and it has to the server has to send the message back to C2 and C3. So what it will do is that it will what S1 will do, it will log an entry into the message table, and then it will create two entries into the inbox table with user ID equal to C2 and user ID equal to C3 with delivery status received. Now what S1 will do is it will call the coordinator to sort of fetch the server IDs for C2 and C3, and then it will be the same flow as the peer-to-peer message delivery, wherein S1 will sort of uh, in case of C2, since S1 is the server itself, so it will directly send the message via the WebSocket connection to C2, and in case of C3, it will just send the message into the Redis pub sub to which uh, S2 is subscribed. Uh, so if basically we are just generating one message per client, uh, and the system will sort of deliver that message throughout by the same core flow.
Where is
Uh,
that group and all of that?
you want the database table.
Yeah, and also like when S1 is sending, right, it will be sending for the rest other all participants, right? So you have to figure out from which table that you're figuring out this group ID, get out all the participants, right? Then so all of that you'll have to talk about.
Okay. Cool. Let me just the group table, message table, and logs table. Okay. So let's assume that in this particular scenario, the the WebSocket connections are already done, and there is a coordinator node uh, to which these particular servers are talking to. Now, what happens is that, let's say client one wants to send a group chat message. Uh, so and all C1, C2, C3 are part of same group. So now what happens is that this particular message from client one calls this send message API, and inside the send message API, it will pass in the group ID instead of the receiver ID, and the sender ID will be client one. Now, server one will receive this particular message. It will log the entry into the message table, and then it will call this group table, and for this
Sorry to
group ID,
somewhere I feel that there should be a group service, right? Who should be able to take the decisions on behalf of what is really happening, correct?
yeah,
Messages just won't go there. So this is just a feedback there. So
yeah, there will be a group chat service. Uh, so so the server will call the group chat service to sort of fetch the group metadata, that what are the list of users that are connected to a particular group, and the group chat service will send as a response to the server the list of user IDs that are connected to that group, and then what the chat server will do is that it will log one message per user ID who is connected to that group with a delivery status as received. Now, post that, what will happen is that the server one will call the coordinator node to fetch the list of server IDs to which these group users are connected to, and the coordinator node returns back that the data that C2 is sort of connected to server 1 and C3 is connected to server 2. Now this data the coordinator node returns back, and now what happens is that server 1 already has the connection to C2, so it will uh, update the status of the it will send the particular message to the C2, and it will update the status in inbox as sent, and it will, for C3 it will send the message to the Redis pub subtopic to which S2 is connected to, and then S2 will sort of send the message for C3 to the C3, and it will update the status of C3 for this particular message ID. It will update the status to send. Uh, that
I have a question.
Mhm.
So, what would happen? Let's say it's a negative scenario, but S1 sends message to Redis that this message has to go to S2.
Mhm.
What happens if client get disconnected and connects to different server? Let's say S3. Then how would you deliver that message?
Okay.
This is, I think, common scenario.
Mm. So, tell me one thing. Like, again, I do not have experience working with WebSockets, but let's say S2 tries to, let's say client C3 got disconnected in between, and currently the coordinator does not have that information that C3 is disconnected. Uh, Now S2 tries to send the message to C3 over the WebSocket, but that message delivery will get failed, right?
Yes.
Because C3 is disconnected. So the update of a particular message that it has been delivered as sent, uh, that update happens after the message has been sent through the WebSocket connect.
Mm-hmm.
So uh, if the client got offline, then we do not update the delivery status as sent. So in that case, what happens is that the client, once it comes online, it will call the get message API, and via the chat history service, it will be able to fetch all the historical messages from the inbox. So all of the messages which are in the received status, that will be delivered at that point in time.
Okay.
Somehow the interpretation of sent is wrong. When you say sent, it is received by the server, right? Which is S1, and
No,
now
received is received by the server. Sent is sort of this is the single tick that you see on the message. Uh,
Forget about the client side update. This server side I'm interested in. So basically, this is status is server side status, is it?
so received is the server side status that the server has received the message. Sent is a client side state. Sent is a client side status that the server has been able to successfully send the message to the client.
But how would server know that C3 received this?
So
So they are communicating over WebSocket, so it will send back that status, is it?
yeah, that is what I am assuming. Like that
no,
WebSocket would have some kind of
that is delivered. When I say what my understanding of sent is that, let's say if I do not have a network on my phone, right? So then that phone is not really sent. I mean, so that message is not really sent.
okay. Hmm. I think the status duplicate हो गया है फिर यहाँ.
Mhm.
Hmm. I think ये
Okay, so let's say as C3 could deliver new message, so who is going to perform that? So you're saying once client C3 again comes up, it will connect to some server, and
it will call the client will call the get message API,
it will
and
call the get message API.
client will itself call like startup पे जब वो connect करता है chat server पे, तो
No,
उसके
I
बाद it will call the
disagree
get
on
message.
this. I somehow disagree here. See, now when S3, right? Just go to the below diagram.
Mm-hmm.
I somehow see S2 really knows, right? S2 really knows that if I'm able to send the message to C3 or not, right? Because it knows that I have an active connection, correct? If it gets disconnected here, right? That means what? S2 has failed to deliver that message,
Mm.
Correct.
right? So then there can be retry mechanisms that should get triggered. Okay, I'm just throwing it loud.
So, a retry would be something like a push mechanism that S2 tries to redeliver the message to C3. Whereas the
No,
this
then,
API
then
is
no,
a
but then as per Kuldeep, right? He's saying let's say there is another instance. Let's say S10, right? C3 gets connected to that S10.
hmm,
Now C3 won't connect back to S2 again.
correct. C3 won't connect back to S2. So that is why this particular functionality that when C3 is connected to a chat server, it will just uh, call the chat history service to get a
The point is, this has a potential to like message go into black hole. Okay, I'll tell you the scenario. So by the time S2 is trying to send message, it find out that nothing is customer is not connected, but customer is already connected with S10. So when connection happen, it will do get message. There is no message, right? That message is still with S2
No, the message is already logged in the inbox, right?
inbox. So all the message you are logging in inbox.
Correct. So S1 will itself create the entries in the inbox,
Okay.
and then S2, when it is able to deliver it to the client, then the status is updated to delivered.
So
This is
message can
again,
be delivered twice.
no, message won't be delivered twice because uh,
Why?
Because the client really knows that what is the set of messages that I have, right?
hmm,
And when it queries, right, it will
Yes. So
beyond it,
correct. Yeah,
right?
that's a correct point. That the dedupe happens on the client device. So message might be delivered twice, but the dedupe, my device is deduping. So I have WhatsApp. It will dedupe that I already received this message ID. So I ignore that.
Yeah, yeah. I I I,
um,
I I got your
I
point.
would slightly disagree. Like, why do you guys think that message would get delivered twice from the
Exact
server?
scenario. So message can be delivered twice because you are putting the message into inbox. S2 is still not delivered, but let's say client connection is exactly fine. There is no problem. S2 will try to deliver, but in between, let's say uh, something happens and I call get message because it is not able to update the status back into DB as a sent or delivered, something like that. But message is delivered to C3, right? But the status is not updated. But I disconnect and connect to S10. I'll go and say that give me my history. It will say that it's not delivered. It will deliver me again, right? So
Okay.
that is the scenario.
Mm.
Somehow we have left that message dangling right there at S2. What Kuldeep is suggesting, right? Because what happened is it went to the Redis, and by the time S2 pulls it out from the Redis, right? And C3 got disconnected. Now what happens to that message? That will be like dangling around right there.
नहीं, but उस केस में तो मैसेज इज इन द रिसीव्ड स्टेटस ओनली. सो ये डिलीवर्ड वाला प्रॉब्लम तब आ सकता है, लेट्स से
But
कि
what I'm saying is there is two transactions is happening, right? One transaction I am delivering message to C3, another transaction I am updating the status. So there is a gap in between. And what could happen and what Pratik mentioned is client side deduping is needed here. That's what we are trying to debate. So until unless my device or customer device dedupe it, you will get two messages. Certain scenarios. Not for all, but yeah.
yeah, that possibility I agree, that deduping is required on the client side.
Yeah, and for dangling, I think S2 can go and update the inbox that it is failed or something, and then drop the message simply.
Yeah, but these messages are these inbox messages are not dependent on the particular server to which is
No, no, but
responsible for.
the status is getting updated from server only, right?
But
Server will say
the
that
status
it's
will get
different.
updated only after it has been, like, there is no failure scenario over here, that reason being that, let's say S2 was able to deliver the message, but it failed to update the status over here.
Yeah.
uh,
Then those
the
messages would be delivered twice, right?
those will be delivered twice, but uh, okay, let's say we update it in a failed status, then then what do we do? Do we not deliver the failed messages
Okay, we have
again?
to deliver. So, okay, in my opinion, I think client side deduping should be needed because there are some time delay when the message is getting delivered, when the status is getting updated, right? And that status update that can fail.
Hmm.
Okay. Yeah, but the point that I mentioned initially, we spent 1.5 hour. We could just discuss the message part, right? So it is very important to set the expectation initially that I will discuss about message delivery, messaging, and all, not any status and other thing.
I'll stop the recording. And anything else that you want to cover, Prashant?
No, I think that was pretty much it.
Sure. I'll just stop the recording and then we'll discuss.
Yeah.